In this lecture, we're going to talk about the distance and midpoint formulas. Before we can talk about the distance and midpoint formulas, we need to discuss rectangular coordinates. So, the rectangular coordinate system is comprised of a horizontal number line, which we call the x-axis, and a vertical number line, which we call the y-axis, that intersect each other at 0, which is called the origin. So when we graph in rectangular coordinates, we use a set of axes that look like this. Now we'll talk about ordered pairs. The position of a point in the rectangular coordinate system is represented by an ordered pair. The first number of the pair is the x-coordinate, and the second number is the y-coordinate. So, for example, we have the point P defined by the coordinates 3, 2. Remember, the first number is your x-coordinate and the second is the y-coordinate, so our x value would be 3 and our y value would be 2. If we wanted to graph that in the rectangular coordinate system, we would go over to where the x value of 3 is, and go up to where the y value of 2 is, and then make a point where those two would intersect. So the point P would lie where x is equal to 3 and y is equal to 2. So, let's try an example. I want you to try to plot the point Q with ordered pair -1, 1. So Q with coordinates -1, 1 will be the point that goes to the left by 1 and up by 1 if we're starting at the origin. So it has an x-coordinate that corresponds with -1 and a y-coordinate that corresponds with +1. And when talking about the rectangular coordinate system, an important concept is the concept of quadrants. So the x-axis and y-axis splits your space up into 4 distinct regions that we call quadrants. And the quadrants tell us something about the values of the coordinates of our points. So, for example, quadrant 1, which is in the upper right-hand corner, both x and y are positive. We number our quadrants going counterclockwise, so quadrant 2 will be the upper left-hand corner, and in quadrant 2, x is negative and y is positive. Continuing in our counterclockwise motion, quadrant 3, which is in the lower left-hand corner, has x and y both being negative. And finally, quadrant 4, x is positive and y is negative. Alright, so let's talk about using the distance formula. By definition, the distance between 2 points P1 with coordinates x1, y1 and P2 with coordinates x2, y2, denoted by d of P1, P2, is given by the following formula. d of P1, P2 is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So let's do an example. Find the distance between P1, defined by the coordinates -4, -3, and P2, defined by 6, 2. So we start with our distance formula. The distance between P1 and P2 is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Note that it doesn't matter which point you use for x2 and x1 as long as you keep the order the same. So if we're using P2 to do x2, we have to use P2 to do y2 as well. So, plugging in the values that we know, our distance will be the square root of 6 minus a -4 quantity squared plus 2 minus a -3 quantity squared. We simplify what's inside the parentheses. So 6 minus -4 gives us 10, and 2 minus -3 gives us 5, so that's the square root of 10 squared plus 5 squared. We evaluate our exponents. 10 squared gives us 100, 5 squared gives us 25, and when we add those together, that gives us the square root of 125, which we can simplify. Remember, to simplify a radical, you want to try to rewrite the radicand as a product of a perfect square and another term. Well, 125 can be rewritten as 25 times 5, and since 25 is a perfect square, we can pull it out of the square root sign, giving us 5 times the square root of 5. Let's do another example. This time, we want to find the distance between the point Q, defined by coordinates -1, 0, and the point R defined by coordinates 2, 4. Take a couple minutes and see if you can use the distance formula to find the distance between these 2 points. Once you think you have an answer, then continue the lecture. So again, we start with our distance formula. The distance between Q and R will equal the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Again, it doesn't matter which point we use for our 2's and which one we use for our 1's, as long as we keep it the same throughout the entire problem. So let's let R be this point where we use subscript 2's. So plugging what we know into the formula, using R as our second point, we'll have the square root of 2 minus negative 1 quantity squared plus 4 minus 0 quantity squared. We simplify the addition, giving us the square root of 3 squared plus 4 squared. We evaluate the exponents. 3 squared is 9 and 4 squared is 16, so we have the square root of 9 plus 16. If we add 9 plus 16 together, that will give us 25, and the square root of 25 is 5. Finally, we want to be able to use the midpoint formula. The midpoint is the point that falls in the very middle of the segment between 2 points. So by definition, the midpoint M of the line segment from point 1 defined at x1, y1 to point 2 defined at x2, y2 is given by the formula M of p1, p2 is equal to x1 plus x2 over 2 as the x-coordinate and y1 plus y2 over 2 as the y-coordinate. So let's do an example. Find the midpoint between point 1 defined by coordinates 2, negative 3, and point 2 defined by coordinates 4, 2. To find the midpoint, we'll need to use the midpoint formula, so the midpoint between p1 and p2 is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. If we plug the information that we know from our points into the formula, we'll get 2 plus 4 over 2 as our x-coordinate, and negative 3 plus 2 over 2 as our y-coordinate. We simplify the addition in the numerators to give us 6 over 2, comma, negative 1 over 2, and then we simplify our division, and our midpoint will be the point 3, comma, negative 1/2. Let's do one final example. For this one, we want to find the midpoint between the points Q, defined with coordinates negative 4, negative 3, and the point R, defined with coordinates 2, 2. Again, I'd like for you to take a couple minutes and see if you can find the midpoint between these points. When you think you have an answer, continue the lecture. So we start with the midpoint formula. The midpoint between Q and R will equal x1 plus x2 over 2, comma, y1 plus y2 over 2. Again, it doesn't matter which point gives us our x1s and which point gives us our x2, as long as we keep those in order throughout the entire problem. So let's let Q be x1, y1 and R be x2, y2. If we plug these values into our formula, we'll get negative 4 plus 2 over 2 for the x-coordinate and negative 3 plus 2 over 2 for the y-coordinate. We simplify the addition in the numerator to give us negative 2 over 2, comma, negative 1 over 2. And if we simplify using division, that's going to give us the point negative 1, negative 1/2. So our midpoint between Q and R is negative 1, negative 1/2.